Are we live yet?
We're live, you can start.
Hello everyone, welcome to today's live session. I'm going to be speaking about Solidity Syntax, the syntax of Solidity. So Solidity is the programming language that is used to write smart contracts, and it's similar to JavaScript. If you've heard of JavaScript and probably use JavaScript language, it's similar to JavaScript and C languages. And it's also an object-oriented programming language. So when it comes to the syntax of Solidity, it is case sensitive, meaning that when defining keywords or variables, you must use the correct syntax. For instance, when lower cases is supposed to be used other than uppercase, you must obey the syntax. That's how it works. So for today's outline, I'm going to be talking about variables, data types, and data structure in Solidity. So starting with variables in Solidity. So variables, as the name implies in programming, are basically storage locations that contain values that can change during runtime. Also, when defining variables in Solidity, the data type of the variables must be indicated. So in Solidity now, when defining variables, like I mentioned, variables are basically storage locations that contain values, okay? So when defining variables in Solidity, there's something you must do. You must just, like I mentioned earlier, it's similar to C languages, and C languages are statically typed languages, meaning that anytime you're defining a variable in Solidity, you must define a data type along with the variable. I'll show you an example soon as we go on. So in Solidity, you can have, you have at your dispense three variables: state variables, local variables, and global variables. So starting with the state variables. So state variables. Also, before I go on, I would like to point out that these variables are defined based on their location and their accessibility within the contracts. By contracts, I mean the smart contract code written with Solidity. So state variables are variables that store the current values of the contracts and are permanently stored in the blockchain or the Ethereum ledger by miners, obviously. So they are basically variables that are declared in the contract and they are not declared within any function. So in a contract, any variable that you find outside of the state variables are basically defined outside of functions in a contract. So as I think I mentioned earlier, I think I wanted to point out something. I think I forgot that, but okay. So state variables are permanently stored. They are permanently stored in the blockchain or in the contract storage. So this means that a certain amount of memory, I mean, when they are being stored in the blockchain, they are stored somewhere. Yeah? So where are they stored? They are stored in the memory. So it means that a certain amount of memory is allocated to store these state variables. So Solidity comes with its own compiler that allocates the memory to the state variable that's been declared. And how it does this is the data type that is being defined by the programmer, it's going to determine the memory that will be allocated by Solidity to that particular variable. When I go further in the session, I would actually explain this, or I think, yeah, right on, yeah, it's actually on my screen. So that this code block you see here, this code block, this is a sample contract called Solidity test. And if you notice, this is a state variable of unsigned integer. So yeah, this simply means that this variable is assigned 4 bytes, because this unsigned integer is it takes 4 bytes of memory and it's equivalent to 32 bits. So this means that the state variable here, which is the stored data, has an allocated memory size of 32 bits. Now, so I think that's all for state variables. And before I move forward, I would like to point out to you something called qualifiers. So qualifiers are basically, they are associated with state variables and to determine the accessibility to determine the accessibility rather. So you have internal, private, public, and constant. So internal comes by default. It comes by default with the state variables. So when you declare a state variable like here, when you declare a state variable like this, by default, it's using the internal qualifier. What does that mean? So it basically means that your variable is only accessible within the contract that it was defined, and also accessible by derived function contracts. So you can derive you can create like multiple functions that's probably outside of this contract, but it's derived from this contract. So in that sense, using an internal qualifier, the variable can be accessible by from the derived function, if that makes sense. So this is the syntax for defining a state variable as internal. As I said earlier, it's by default, you don't have to define internal. Like here, I did not define internal here in this code. So by default, it's using the internal qualifier, but you could decide to use the internal qualifier here. So this state variable is basically just like a variable name. It could be anything. So moving forward, there's the private qualifier. So this qualifier makes your variable only accessible within the contract function. And this is the syntax here. So it uses a private keyword, which represents the tells the Solidity compiler that this is a state variable using a private qualifier, and this state variable cannot be accessed by functions outside of the contract, only within the contract or function it was defined. So for public qualifier, with this qualifier, state variables can be accessed directly via a function that is generated by Solidity called the getter function. So this is syntax. It uses the public keyword. And then you have the constant qualifier, and this qualifier, the state variables cannot be changed. You can't change the name. Constant obviously implies that it cannot be changed, as it's used in other programming languages. So here, when you use a constant qualifier with this constant keyword, with this constant keyword, that's basically what it does. Okay. So moving forward, the second type of variables, I've mentioned state variables, now the local variables. So local variables, as I mentioned earlier, state variables are declared outside functions in a contract, but local variables, on the other hand, are the opposites of state variables in the sense that they are declared inside a function. If you notice here, you have a local variable, you have a state variable here that is declared outside this function, and then you have a local variable here that is declared inside a function. So this is the local variable and this is the state variable. So that's like the difference. So this means that this local variable defined within the function, it means that the variable can only be used within this function in which it was declared. It cannot be used outside of this function. That's what it means. Then it's also considered a temporary storage location. I mentioned earlier that state variables are permanent storage locations, but local variables are temporary storage locations, and they are not stored on the blockchain as compared to the state variables. Local variables are not stored on the blockchain. So when you use local variables, use them in situations where you are processing something, or let's say you're calculating, your business calculator, what you're working on is you're processing something, or you're calculating something, and you're using values, and you want to hold these values temporarily while you're working with them in that present time. So basically, that's when you use local variables, because it is not stored on the blockchain. It's just for that period of time while you're working with those values. So moving forward, global variables. So global variables are variables that exist globally in the workspace and provide information about transactions in the blockchain. So as you can see on the screen, I listed some of the global variables that are available in Solidity. I have the block dot difficulty. So if you notice, these global variables have their distinct data type. for instance, this block and the difficulty is a global variable of unsigned integer type. And this block the gas limit is also of unsigned integer type. This is of type address and all of that. So each of them have their various functions. And for this block the difficulty, it's basically used to store the current block difficulty. To store the current difficulty of the block. That's basically what it does. That's basically what it stores. Then the block dot gas limit is for storing the current block gas limits. Then block dot timestamp is for it stores the current block timestamp as seconds and all of that. Then you have the message dot sender as well. So the message dot sender, what does it do? It sends, it basically stores the I think the sender of the message. You can know who's sending a particular message by using this message or sender. If that makes sense. So it uses the address type because it actually stores an address, the address of the sender, and it uses the address type, as you can see. Then this payable is like it's a qualifier that comes with Solidity, and basically tells you that okay, how will I put it now? It can basically accept transactions, or it can basically accept Ether and all of that. So tx.origin, that one is for basically stores the sender of the address of the sender of the transaction. That's who's sending the transaction. Then gas price, tx.gas price is basically the gas price of the transaction, stores the gas price of the transaction as an unsigned integer type. Then message.value, it stores the number of way that is sent with the message, basically. So those are just a few. There are actually more. You can do research on more of them and all of that. Then in Solidity, you have various data types. You have the Boolean, you have unsigned integer and integer, you have bytes and strings, you have kind of repeated this here, but like bytes, you have strings, then you have address, mapping, enumeration, and struct. So I'm going to like give you like an example of each of them and give you like a quick explanation of what each of them stands for, what they are used for. So for the bool, so the bool stands for Boolean, and Boolean is a data type that accepts only two values, true or false, like in other programming languages. Then the integer data type that is used to store integer values as whole numbers, that it stores whole numbers basically, and unsigned integer stores positive. If integer actually stores positive or negative values, while unsigned integer actually stores 0 or positive numbers. Then bytes are data types that are used to store a fixed sized character set, and it has a length of 32 bits. Yeah, so it's like from a length of 1 to 32. And then you use bytes when you use the byte data type when you know the length of data that you're working with. And for string data type is used for dynamic length of data. I mean, like when you want to store it's used when you want to store the character sets equal to more than a byte, basically. So it's used when you have a dynamic length of data. That's when you use like the string data type. Then for address holds a 20 byte value, which represents the size of an Ethereum address. So an address can be used to get balance or to transfer balance. So it has there's a balance method, there's a transfer method that can be used when working with the address data type. Then the mapping data type is a data type that basically stores data in key value pairs. So if you've worked with dictionaries in other programming languages, you have like like a clear understanding of how mapping works and all of that. So mapping is very similar to how dictionaries works in other programming language. And how does it work? Like I said earlier, it stores data in key value pairs. So the data is basically retrieved by using the key. In a dictionary, when you want to retrieve data, you use the key, right? So it's the same thing in mapping, the same way it works. So the data is also retrieved with a key. Then I think address. Okay, I mentioned address and I'll discuss enum later, but I think I could just go on and discuss it now. Okay, so enums are actually used to create user-defined data types or a set of named constants with an enum keyword. And each of the constant values is assigned an integer value from 0 to 1, and also it does not end with semicolon. So I'm going to show you how it looks like, starting with Boolean. So this is how a Boolean looks like. So this is the bool data type. This is a public qualifier. Then we have the this is a Boolean. Basically it's Boolean actually, but that's like the variable Boolean, and we set it to false. So it can either be true or false, like I mentioned earlier. Then this is the integer data type of int. And this is like the variable. This is like the variable, could be anything. And notice it could be negative or positive. Then string, this is like for string. So this is the string data type. And then we have bytes. I don't think if I talked about bytes, but I think I did. Okay, so yeah, so that's this for bytes. And then okay, yeah. So this for enumeration. So as I mentioned earlier, I said enumeration actually is used to create user-defined data types or a set of named constants with an enum keyword, as you can see, and each of the constant values is assigned an integer from 0 to 1, and also it does not end with semicolon. So in this, yeah, I think that's that for that. So yeah, so this is how you basically, this is a function that is returns the enumeration here that was defined and all of that. So this is how it actually returns the enumeration and all of that. So moving forward, struct. So struct is another data type. So a structure can also be called struct. So when you see struct, it's actually structure. So a structure can also be called struct, and it's simply a data type that consists of multiple data types. So it's they are defined like contracts, but like you can see, they're defined like contracts, but they do not contain code, and they just contain these multiple data types of string. You can see string, assigned integer, boolean, and all that. So when do you use struct? When do you use a struct data type? Anytime you have to store multiple data that are related to each other. For instance, let's say you want to store information about a student, like their names, ages, origin, status, and all of that. So you can use the struct data type to define them. And then this is how you create an instance of it. When you define a struct, the struct keyword, this is like the identifier of the structure. So when you define the struct using the structure, when you define the structure using the struct, then you can create an instance of the struct by calling the name, that's the identifier, and then passing in the values that corresponds to each of, like this is a string, this is an assigned integer, this is a boolean, and this is like a string. So it has to correspond. This is how, and you can also call multiple. You can also create multiple instances, rather. You can also create multiple instances. That's why I like outline this here, creating another instance of this struct. So it basically allows you to, it's flexible. You can keep using this struct again and again and again and again and all of that by just creating multiple instances. Then mapping. So mappings is a data type that stores data in key value pairs. So okay, yeah. Okay, so basically you declare a mapping using the mapping keyword, followed by data followed by data types for both the key and the value. Notice these are the key, this is the key and this is the value. So this is the data type, this is also data type. So mappings are declared using mapping keyword followed by the data types for both the key and the value, and separated by this notation here. So mappings have identifiers like any other data type, and like this name here is an identifier for this mapping. And this identifier can basically be used to access the mapping. So anytime you have to access the mapping, you can actually use it to access it basically. Yeah, so I think I've covered all of that. So moving forward to data structures. So data structures, basically in Solidity, we have arrays, structs, and mappings. I've already talked about structs, and I've also talked about mapping. So I'll just talk about arrays briefly. So arrays are simply groups of values of the same type. And in Solidity, arrays can be either fixed or dynamic. Also, there are actually special arrays, but I didn't actually mention it here. But like there are also special arrays, but I'm mentioning just these two, the fixed arrays and dynamic arrays. So in fixed arrays, you can declare an array. At the same time, you can define its size. Here you can see this represents a fixed. This is an array, yeah. This is an array of integers with 5 fixed storage space allocated. This 5 here is basically the 5 fixed storage space allocated. And this is like the name, the identifier of the array or whatever, name of the array. So that's basically it. So that's how it works. Then also this is like an array of bytes. You can also have an array. You can have arrays of different data types. So here this is an array of integer. This is an array of bytes. So this is an array of bytes with 4 fixed storage space allocated. So this is how you define an array in Solidity. And this is like a fixed array because it's a fixed array because you are at the same time while you're defining the array, you're also defining the size of the array, which is this in this square bracket, which are the numbers actually in the square brackets. So dynamic arrays, I don't think I put that about. Dynamic arrays basically is like the opposite of fixed arrays. Instead, like you do not define the size while you are defining the array. So in dynamic array, you won't have this 5 here, you won't have this 4 here. It's just going to be empty. It's going to be empty. So dynamic arrays, they also determined at runtime. That is why you do not the size of the array actually of a dynamic array is actually determined at runtime. So you do not need to specify the size of the array while you're defining the array. That makes sense. So that's basically it. So I forgot to mention that if you have any questions, you can actually place them in the comment section, and I can actually take questions now. I think I'm done. So if you have any questions, please.
Okay.
Yeah.
Oh yeah, we have a few, actually very few questions. So the first question I have here is, I don't get the syntax of that for private and others. I don't know if this is a question, but it's obviously not.
Sorry?
Okay, so going to the next one.
Okay.
Explain more on transaction.origin and message.sender. Like, what's the difference?
Okay, that's tx.origin. So okay, so tx.origin basically send out the transaction, and okay, I think I should just go back there. Tx.origin and message to sender. Okay, yeah, okay. I get why it's asking. So
yeah, I think I already gave like a response on in the comment section. I said the contract that you transaction.origin to authorize users, they're actually vulnerable to attacks from hackers. Okay. So whenever you want to use whenever you want to do authentication in your contract, it's better for you to use the message.sender because you can use it as a contract address and as a externally owned address. Unlike the transaction.origin that can only be used by an externally owned address.
Okay. I actually get the person because I was actually confused at first when I actually learned it for the first time. So basically, the message of sender is the caller of the transaction, is the address of the caller of the transaction. Basically, the person calling before a contract is created, you have to call a function, right, in the contract. Before a transaction is created, sorry, you have to call like a function in the contract. So the address of that person calling the function is actually, that's what the message of sender stores. Then the tx.origin is the address of the sender of the transaction. The person sending the transaction is that's basically what it does. The origin and all of that. But I think you should like Google, you can Google it and have like more information. But that's all I can give you for now. I hope it's clear. Are there any other questions?
Okay, so the next, yeah, sure. So the next question is, can we say that struct work like classes in object-oriented programming?
Class, you can actually define methods in okay, somehow, sure. But you define methods in classes and in structs, you're basically just defining variables of different data types, and then it's basically like, yeah, it's actually like methods, but so that methods like methods contain code, but structs, there's no code. There's no code in struct. When you're defining the structure, there's no code. So it's not like class, because in class you have code. Yeah, because in your classes you're defining methods. Yeah, in JavaScript, I don't know for that programming language, but in JavaScript and Python that works with, you define methods and you use code. But in structs, there's no code when you're defining structs. It's just there.
More like an object of the class instead of the class itself. The contract in this case is the class.
Yeah, I hope. Okay, yeah, I get.
Okay, so the next question we have, what is pure from enum function? I'm not sure I understand this question. What is pure from enum function? I'm not sure. Tajuddin Olariwaju, can you please rephrase your question? Okay, and the next question we have, how do I define and use a fixed array in Solidity?
Okay.
Maybe you need a practical on that. Or...
I'm actually going to the screen. Okay, this is for the fixed array now. This is how you define a fixed array here. I mentioned it. I said this is an array called age, and in fixed arrays, when you're defining fixed arrays, you must define a size. The size. Like now, this is an array of integers, yes, and it contains it's a 5 fixed storage space. It has just 5 storage space allocated. If it was 10, it would be 10. It will be 10 fixed storage space allocated. If it was 20, it will be 20 fixed storage. That means this array can only accept 5 integers. That's the only thing you can actually accept. You cannot accept more than 5 integers. That's basically it.
Okay, I think we have one last question here. Someone says, can we say structs are objects now?
Structs are not objects, Obiko. Structs are not objects, please. They are not objects.
Okay. Okay, so.
Sorry? Is that my network? Sorry, I can't hear anything. Can someone say? Okay. Please, can you come again? I didn't hear you.
I said, okay, I understand that it's not like a class, but then it's not a class, because in this case, our contract is a class. And then the objects, it might not necessarily be like objects. Can you guys hear me?
Yeah, we can.
Oh, okay. Yeah, I'm saying that it's not necessarily an object, but it is like an object, because an object has properties. A Solidity, a struct also.
Is he talking about structs? Oh, structs.
Yes.
The structs for properties. What do you mean by properties?
No, I mean an object has properties. Like they have.
Okay, yeah. But structs do not actually have properties. Structs are you're just defining multiple data types. When you have like data types that are related to each other. I'm trying to go back to where I mentioned it. Are related to each other. Where is it? Structs. Okay, yeah. I used a student as an example. I said if you want to store information about a student, I know a student they have names, they have ages, they have like subject, courses, and all of that. If to store that related information now, you can use a struct because you're going to be reusing it in your contract or whatever. You're going to be, so I think the person is confusing it because we're actually creating an instance from the I think this is why the person is calling it an object because he had instance. So I guess that's why. But this is what it was. And if you're defining objects in JavaScript, for instance, I mean you're going to be using um, properties and all of that. You have like a colon and all of that. You're not doing any of that here. So it's actually not an object, not even close to an object. If that makes sense.
Okay, we have another question. What's enum function? Still finding it difficult to understand.
Okay, enum. Okay, let me come again then. Also, enum, let me go back to it. Okay, so enums are used to create user-defined data types or a set of name constants with an enum keyword. And each of the constant values are assigned an integer value from 0 to 1. So this is 0, 1, and this is 2. So they are used to create user-defined data types, basically. Okay, I understand why the person is confused. I didn't give like so much explanation on this, but you can DM me on Discord and I'll like give you like a good example and probably explain it better.
Okay. In the code sample where you showed enum, there is a pure qualifier in the code. How does it work?
It's okay. I mean, this code is basically not. It's just returning. It's not doing anything. It's just returning. That's just returning, and it's not like it's not. There's no code in it. It's not carrying out any function rather than returning the enumeration. That's why it's used. That's why I think there's another way I can put this. I'm trying to think.
Yeah, you can use returns, then add the my enum give. So add them together instead of adding a statement again.
Yeah, like I'm trying to like use another means to explain another word to explain the pure for the person.
Oh, I think for pure, there are two types of visibility in Solidity. We have the view and the pure.
And the pure, yeah.
Right. Yeah, so the pure allows you to read and write into your code, and the view allows you to just read and not write.
Yeah, right. That's true. Okay.
Okay. We don't have any more questions. If you have any more questions, please drop it in the comment section. And if your friends are not here, kindly call them. Tell them that we are sharing money so that they will come. You understand?
Okay.
If you have questions, you can drop them. Okay, is that all on the lecture?
Yeah. I think I got it now. Like, so basically this pure using the function is you can use pure as a qualifier for any function that you know is not modifying the state of your transaction or your contract or state of your contract. So that's why I said it just returns this function just returns this enumeration. There's no code, like it's not performing any function like a code or anything. Do you get? So it's not changing anything. It's not changing anything. It's just returning. That's why I use the pure qualifier. Yeah. So I think I've come to the end. Yeah.
Okay. Esadu is our tutor for the night. Okay, it's our one and only Deborah Emeni.
My name is Deborah Emeni. If you need my account number, I could probably send it to
I don't know why you're asking for a name, but you can ask for a number.
He probably wants to send me money again. You can DM me on Discord. Okay. All right. Thanks for having me. Bye, everyone. Bye.
Okay, I think we've come to the end of the class. If you have further questions, you can drop it on the general help or technical help. Thank you.
Bye.
Thank you, everybody. The co-host is actually Eniola, for those of you asking.